Hello everyone, Pem here once again. Welcome to Owasp mobile threat number 4, which is insufficient input and output validation. And as usual, we define the vulnerability, walk through how attackers exploit it, outline the preventative controls, and finally review the business impacts associated with this weakness. So insufficient input and output validation refers to a class of vulnerabilities where mobile applications fail to properly verify, sanitize, validate, or encode data received from users, external sources, or even other applications on the device. Likewise, data leaving the application may not be correctly encoded or masked before being logged, stored, or transmitted. In other words, the application trusts data too much. Because of this trust, malicious data can pass through the system and trigger unintended behavior, including injection, unauthorized access, or a sensitive data exposure. Now, how this can happen is attackers take advantage of validation gaps in multiple areas of a vulnerable mobile application. Consider these examples. First, a user input field, such as a search bar, or a login field without strict validation that may allow an attacker to send crafted payloads that manipulate back-end databases. And next, which is quite interesting in mobile applications, deep links and app links. This can be injected with unauthorized parameters that lead users to fraudulent screens or trigger privileged actions within the application. Another attack path is inter-process communication, such as Android intents or content providers. So if your mobile application accepts data from another local app without validation, a malicious application can inject harmful data directly into your workflows. And we also see attacks where files or media are read without verifying their structure. In these cases, manipulating metadata can result in logic bypasses or code execution. And finally, deserialization of untrusted data, which is a very high risk threat. A malicious serialized payload can exploit the parser and compromise back-end systems once it reaches the server. Now, each of these scenarios has a common theme: unvalidated, trusted input in, and unexpected behavior out. Now, preventing this kind of attacks requires strong discipline in both input validation and output encoding without exception. First, you need to validate all inputs using allow lists, only accept non-good data types, formats, and ranges. This applies to user inputs, deep link parameters, IPC calls data, and any file or media read by the application. Secondly, you need to enforce validation again on the back end. And remember, mobile applications are not trusted clients. The server must never process data without its own validation checks. Thirdly, you need to protect against injection by using parameterized queries, schema validation for serialized data, and strict parsing rules for file formats. For outputs, mask or redact sensitive values before writing to logs or caches. You also need to apply output encoding when rendering or transmitting data to prevent injection into downstream systems. Finally, you need to reduce your attack service. Limit exported Android components, restrict permissions, and disable unnecessary debug logging and error messages in production. Now, the business impact of this kind of attacks emanating from insufficient input validation is reputational damage, information theft, fraud, and unauthorized access. The bottom line is clear. Weak validation creates a direct pathway to data breaches, fraud, and regulatory exposure. And in summary, the risk number 4 highlights a fundamental security principle: never trust, always verify. Whether it comes from users, files, other applications, or even your own mobile clients, you need to treat all inputs as potentially source type and reinforce every control on the server side. This our URL, come back here, paste it here, and then also let's copy our payload, copy, paste it there and save. So if everything is going to work, then we are going to have this XSS executed inside our phone. Okay, so let's start Frida again. We exploit again here our script by Frida, and then enter. So here we are. Okay, so let's click on it. As you can see, our exploit is executed on this application, and it is on this application. As you can see, it's still on this vulnerable web view. Okay, now that we have XSS executed, we want to exploit this application further to see whether we can be able to execute our own code. Now the next vulnerability that is associated with web view is arbitrary code execution. So let's see how we can exploit that code. Okay, so I had created this execution code here. We can check on it. We want to display whatever we want to call this method inside the application using the Android parameter. Okay, that I had shown before. Let's point our Frida script to this method here. Okay, let's save it and close. Let's start our Frida server again. Then let's execute our scripts. Okay, I think that is okay. Let's execute it. Let's click on this web view and see what we are gonna get. As you can see, this method has been called. Okay, super secret code. So that is it for now. See you and you're welcome.